Okay, guys, today we're going to talk about program evaluation and review technique charts. That is called PERT charts for short. The basic thing we're going to talk about here is activity graphs, and this is going to help you with building a robot, your assignment that you're going to do after we do this little lesson or after you watch this video. Suppose you're in charge of organizing the senior class party. The following is the estimate of the time required to perform all the necessary activities. So you got to plan your music playlist. You have to download music, buy groceries and decorations, bake cake and prepare food. Also, you got to set up for the party. Each of these numbers represents how long these activities take you. And you have to figure out how much time you need to get this activity planned, how much time you need to organize everything. So since there are several classmates helping, some of these activities can be performed at the same time. For instance, people can begin setting up the decorations while the cake is baking. However, you cannot bake the cake or set up until after you've been shopping. And you cannot begin downloading music until you know what songs you want to download. So the following activity graph can be used to help organize this information. Again, here's the information we're looking at. And here's the activity graph. From the start, we're going to take the activities we have to do first. So we have to first plan the music playlists. And then second, we have to go grocery shopping. We have to do those two things first before we do anything else. So what do the numbers in this graph represent? Well, the numbers represent the time in hours each activity takes. Why is there an arrow going from A to B, but not going from A to C? Well, basically from A to B, those two activities can go one right after the other. They're related to each other. You have to first figure out the music you want, then download it. That's what A to B is. And C is buying the groceries. So it doesn't matter what music you want when you need to go buy groceries. So that's why A and C start at the same time, and there's no need for an arrow from A to C. Okay, so beginning at the start, there are several paths through the graph following the arrows that end at finish. For each path, calculate the total time required to perform all the activities along that path. So first, if we go along this path from A to B, that is 1.5 hours. The second path we have is going from C to D. That takes 3.5 hours. And then the third path goes from C to E. That takes 4 hours. So what's the minimum amount of time required to perform all 5 activities? Well, if it only takes an hour and a half to plan the music and download the music, that's not the minimum time. We only get 2 activities done. If it takes 3.5 hours to go grocery shopping and bake the cake, well, we still have got to set up. So buying the groceries and setting up is 4 hours. So the minimum time here is 4 hours required to perform all 5 activities. Which path corresponds to this minimum time? The path going from C to E corresponds to the minimum time. It's pretty strange that the minimum time we asked about in this question is actually the longest path in the graph. And those activities are buying groceries and setting up. Everything else can be done while we're buying groceries and setting up. Everything else can be done. Which activities could take a little longer to complete without affecting the total? Well, we could take a little longer to plan the music, take a little bit longer to download the music. Maybe we could get more music. That take 1.5 is the path from A to B, but we have 4 total hours. So that gives us an additional 2.5 hours that we could take to download and plan the music. So we could take more time to do A and B activities. We could also take more time on D, because the path from C to D is 3.5 hours. That gives us an additional half hour to bake the cake, and prepare the food. So scheduling classes in college can be very similar to the previous scenario. Over 4 years, there are certain classes that you must take. They're called prerequisites, classes that must be taken first. So suppose you need to take the following classes with the identified prerequisites. You have to take Calculus 1 and Calculus 2, but look, you can't take Calculus 2 until you take Calculus 1. Same thing with physics. And then you have to take Physics 2, but you can't take Physics 2 unless you take Physics 1. And then you have to take argument and debate, but you can't do that until you take speech. So we need to first create a start and finish square. So we did that, check and check. And then any activity or any class that can be performed right away means there's no prerequisites. We're going to use those right by the start. And then we're going to arrow from class to class to figure out how this could go. So the first 3 classes that don't have prerequisites are Calculus 1, Psychology 1, and Speech. So we're going to take these 3 classes and we're going to start those first. So now the next level of our graph, we have Calculus 1, which is a prerequisite for several classes, and since we're done with taking Calculus 1, when we move on to the next step, we can take Physics. We can also take Calculus 2 at the same time, because those have the same prerequisite, Calculus 1. And then we can also take Argument and Debate. So the arrows that we draw in our graph is based on the prerequisite classes. Well, we have Calculus 1 before we take Physics and before we take Calculus 2, and Speech has to be done before we take Argument and Debate. But Psychology 1, there's no prerequisite for that, and there's no class that we have to take after that, so we can just take that one all the way to the finish. And then we have one more class that we have to take, this Physics 2. Now this Physics 2 has a Physics 1 prerequisite. So the Physics 1 has got to go up to the Physics 2. And then Calculus and then Argument and Debate, they all go to finish. Now we need to identify the longest path from start to finish. And how long is this path? So if we start with Calculus and then we go to Physics and then Physics 2, that's our longest path. So now if each class is a semester long, how many semesters are needed to take all these classes? Well, 1, 2, 3 classes, so it's 3 semesters. And if you want to finish these classes as soon as possible, which classes should you not delay in taking? Well, the biggest issue we have here is Calculus 1. Calculus 1 is a prerequisite for 2 different classes. So we have got to take Calculus 1 first. How long could you wait to take Psychology 1 without delaying your overall program? Well, we've said we have got to take Calculus 1 first, and we also know that Speech is a prerequisite for another class. So Psychology isn't a prerequisite for anything. So we could actually wait till the very end to take Psychology. We could wait all the way till the 3rd tier to take Psychology. And we could take it after we took Argument and Debate. But we have got to take Calculus 1 first, then Calculus 2, Physics 1, and then Physics 2. So I could feasibly wait until the very end to take Psychology. And now I didn't have to take 3 classes my first semester. All I had to do was take 2. And now, how long could you wait to take Speech without delaying your overall program? Well, Speech is a prerequisite for 1 class. So we can only wait 1 semester. So we have to take Calculus 1, and we have to take Psychology first. And then after Psychology, we could take Speech, and then Argument and Debate. And then we could take Calculus 2 and Physics the same time we took Speech, and then Physics 2. And then our program looks like this. And it's still 3 semesters. Because Physics, Calculus, and Physics 2 are those 3 semesters. And we have taken every class within 3 semesters. We've just taken them in a little bit different order. Now we're given an activity graph, and the times for each activity are given in hours. So determine the minimum time required to complete all the activities shown. Remember, the minimum time is the longest path. So the longest path is A, C, and E, and that is a 10-hour program. Which activities are considered to be critical? Critical is like that prerequisites that we had when we were choosing classes, and those prerequisites are classes A and B. Those are going to be critical activities. You might consider D to be critical because you have to have D before you can do F and E. But the critical activities are the ones you have to get started first. So those activities are A and B. Now, how long could activity F be delayed without affecting the overall completion time? Now, that overall completion time is 10 hours. And the path that includes F is an 8-hour path. That means 10 minus 8 is 2 hours. That means activity F could be delayed by 2 hours without affecting the overall completion time. And then similar question, what about if F and D were both delayed? Well, if F and D were both delayed, here it's an 8-hour path, so we have 2 hours that we can distribute between activities F and D. So that's 1 hour apiece. Alright guys, that's activity graphs. Good luck building your robot.